This original WSRE presentation is made possible by viewers like you. Thank you.
On the cutting edge of robotics with Google engineer James McLurkin on this edition of Conversations. Science fiction and fantasy help formulate our perception of robotics. But in reality, we're likely on the cusp of robots being part of our everyday lives. Google engineer and adjunct Rice University professor and researcher James McLurkin is at the forefront of the coming revolution. McLurkin was mesmerized by technology and engineering at an early age, a fascination that has made him one of the most respected names in the field of robotics. He's been recognized and celebrated in Time and Black Enterprise magazines and featured on the PBS television series Nova. His expertise has been sought after by such entities as Walt Disney Imagineering and Micro Display Corporation. His academic resume is quite impressive too, an undergraduate, master's, and PhD from MIT, as well as a master's from the University of California, Berkeley. We welcome Dr. James McLurkin to this edition of Conversations. Thank you so much for joining us.
It's a pleasure to be here.
You had a fascination early on with engineering and science. What triggered that?
I was one of those people that really didn't have a choice. I grew up, I never remember a time when I wasn't building something. So it starts with blocks and cardboard boxes and model trains. My dad got me my first model train set at age 4. I don't really remember it, but he had a great time. And then eventually you move on to the pinnacle of all engineering prototyping kits, Lego. And that you know, radio controlled cars, and eventually all these things come together, and you end up with the natural outcome, which is robotics. The integration of electrical, mechanical, and computational systems together into one package, and that's where I ended up, and that's where I've been since forever.
How old were you when you really started making things come together, when you really started inventing things?
My mother would claim that the refrigerator box that I put ice on top of and blew a fan over to make air conditioning, because refrigerator boxes get hot in the living room. Right. She'd probably put the marker there. I'm going to go a little further out, and when I first started really taking things apart at a deep level and understanding the electronics and the mechanicals that made them go. So I'll put the marker somewhere around middle school time frame.
Okay. Now, what was it like when you were in high school? What was your life like as you were coming up and concentrating on this stuff?
So there were two parts of that. Every engineer, high school is a very important time because you finally know enough stuff, enough mathematics, and enough technology to start building complicated stuff. For me, I started working on my first robot in the 10th grade. I knew enough about computers and processors to build a small little computer board using at the time, the venerable 6502 microprocessor, which people who had an Atari or a Commodore, that's what an Apple, right. The same chip was in those computers. I picked that chip so I could write software on my Atari and then program my robot with the same software. So you know this technology. If you're lucky, you have a mentor who understands the technology around you. In my case, I had my father, electrical engineer by training. Okay. But he wasn't up to speed on the microprocessors and the digital logic. So you have this on the bright side. And I also had a public school, that had a wonderful science research skills class. So this was a whole class that was set aside to just work on an independent science project. Fantastic opportunity. My teacher in that class, Eugene Warasilla, had no idea what this robot stuff was, but he recognized that this is important, this is good work, and he set up different competitions and venues and things to put me into. So good stuff. On the bad side, being smart and being nerdy in America is hard in middle school and high school, in particular being smart, nerdy, and black. So the minority community, it's a tough road to walk, because you don't quite fit into the smart, nerdy community. You don't quite fit into the black community. You don't fit into the cool kids. There's nowhere for you kind of to be. So socially, it was difficult.
Right. Do you think that's changing now? Is it because it seems to
It
me it's
is.
more hip to be?
It is. No, geek chic is in right now. There have been a lot of things that have happened. In particular, the revolution of there's been, kind of from the top down pushes of big efforts in STEM and getting STEM resources and trying to build more engineers. And there's also been a bottom up growth of making things, makers, the maker revolution people talk about. They talk about maker spaces and hacker spaces and the revolutions of 3D printing, where now anybody can make a part. You don't need to be a trained machinist now to build a part to do something. The availability of the parts online, not just whole things online, but now you can get just parts. I was online yesterday trying to find a voltage meter for a Nerf gun I'm working on. Because I'm an engineer now, and engineers often have Nerf battles.
Okay.
And knowing exactly the voltage that I'm putting on my motors is important.
Okay.
And these parts are readily available on Amazon or SparkFun or Adafruit, or so there are a lot of things happening. And I saw this firsthand as a professor. So my first few years teaching in 2009-ish, 2010, a lot of the students in my freshman class came in with a vague understanding of how things worked, but not a lot of hands-on experience. Even just 5 years later, many more students had come through FIRST robotics in high school. They'd come through robot camp. They'd come through going to makerspaces on the evenings with their friends and with their parents. So they were familiar with not just screwdrivers and saws and hammers, but microcontrollers and soldering and all manner of advanced skills. So I'm very optimistic for the next 10 years as we put this generation through the education pipeline. As they come out, I'm looking forward to seeing where they end up and where the country goes. It's still the case, though, this is not a time where we can rest on our laurels in terms of encouraging the next generation of engineers and scientists. So my personal soapbox is that engineering is fun. Engineering is fun not just for nerdy, geeky, white male types, but engineering is fun for everybody of all genders, all ethnicities, all colors. And not because it's the right thing to do, but just because it's fun to build stuff.
Right. What should parents and teachers, in your judgment, do to encourage young people to be involved in STEM-related, science, technology, engineering, mathematics? All
right. So step one, as I said, is engineering is fun. And the worst thing you can do as a parent or an educator is take the fun out and put a bunch of discipline, a bunch of rules, and a bunch of stuff. There needs to be some structure, but you gotta let the students figure out what they want to do. Some students are gonna love raising Daphnia and looking at the difference in light and salinity, and other students are going to want to build robots. Other students are going to want to study whether or not the paint color of their room influences their study habits or what have you. So first is don't take the fun out. Second, let the students lead in their interests. Let them follow their interests. Give them enough resources and enough equipment and enough spare parts and enough, at some level, physical support so that they don't run out of whatever resource they have. Their limiting resource should always be, as best as you can arrange it, time. How much time do they have to work on whatever craft they're on? And whatever direction they're going in, your job as the parent and the teacher is to get behind them and get alongside them and help them along that path. So, for example, my father was a trained engineer, so he knew what I was talking about, can guide me and taught me how to solder, taught me how circuits worked. My mother is a speech therapist. So she would see the stuff in my room, but it's some kind of robot circuit thing. But she did know that I had read all the books in the local library. So she eventually got me a library card to the library in the city next door city, which had a larger selection of technical books. I outgrew that library, and she somehow arranged to get me a card at the local college, which was fantastic because now I had access to college-level text on the subjects I was researching or working on. She realized that I outgrew Radio Shack in terms of part selection, so she found a local electronics store that had a full selection of chips. And even more importantly for me, I didn't realize at the time, that store also had the full selection of data sheets for the chips. So I did not know what the chips did. I didn't have to be like, there was no internet back then. So her ability to be basically the chief resource officer in this enterprise of raising me was critical.
Let's talk about robots. What is the biggest misconception the average person has about robots?
All right, so let's just deal with this right out of the box. The biggest problem with robotics is the Terminator scenario, where they get smart, they start talking to each other, and they take over the world, and the very first thing they're going to want to do is exterminate all the humans. And that, for a whole bunch of reasons, that doesn't make sense. It's difficult for me, if we did build a machine that was sentient, it's difficult for me to believe that it's also inevitably going to be sadistic. So there's no reason to assume they're going to want to annihilate all of humanity. The other problem with robotics is what kind of abilities robots are going to be able to do, and where, science fiction versus science reality. And some things are just impossibly hard right now, even for the most sophisticated robots. And sometimes it's surprising. You've heard all the news about self-driving cars. Turns out that particular task, we spent a lot of years building roads that are well outlined, well demarked. We have maps, we have GPS coordinates. There's a lot of information on how to get down a road. There are some things that are much harder than that. I don't know, tying shoes, very difficult. Being able to run and jump across a stream, very hard. You have to understand your footholds, you have to understand, estimate the friction on each rock. These things are very difficult for robots to do right now. Some of these things we're working on. There's good work coming on right here on robot mobility, right here in Pensacola. And self-driving cars, as we know, it's all the rage right now. We will see them. It will happen. The technical hurdles are largely overcome. We largely have cars now that are safe and reliable and can get down the road. The problem now is to figure out the legal challenges, responsibility challenges, and the cultural challenge of accepting vehicles driving for us.
Do you think it'll be somewhere in between initially? So maybe I'm driving the city, I'm hands-on, but if I'm on the freeway, I can, punch I like to refer to it as autopilot, more or less. And I mean, is that probably what we'll see first, do you think?
We're largely already there with that kind of technology. So fancy your cars, you push the button on the freeway, and they'll regulate the distance of the car in front of you. They have lane departure warnings, they have lane nudge warnings. So the engineers are trying to put as much technology into the car as they can without crossing the legal line of who's in charge of the vehicle. And that becomes a legal issue and a cultural issue to debate. If you get into an accident, if your self-driving car gets into an accident, who's to blame? And these are things that we have to figure out the right ethics and the right legality behind this. But on the bright side, this is a task, driving. We're just terrible at it, and we accept the fact that I think it's something like 30,000 people are killed every year in auto accidents. We accept this as, that's just what happens, but that's just nuts. That doesn't make any sense. And if this were, I forget the stat. I want to say it's the #1 killer of teenagers. I shouldn't say this on the air. So it's bad. It's a lot. Bad. Getting people to stop doing that would be fantastic. So even if the self-driving cars are bad, they're gonna be far better than the people-driven cars.
What about aviation? We talk a lot about drones. People are fascinated, with drones. But then it comes, at what point are we going to have a airplane flying passengers without pilots? I mean, is that something that we'll see in the next, 10 to 20 years?
So again, it's incremental progress. So autopilots now have the ability to take off and land airplanes automated. They have the ability to fly cross country. They have the ability to do some simple avoidance behaviors of nearby aircraft. That's not how airplanes operate. Pilots like to land and take out the planes themselves because that's where things get tricky. So you want to be able to have good response, and you want to have your head in that game if something goes bad. If you're taking off from LaGuardia and you have multiple bird impacts with your engines, and you lose both engines. This is the famous Sullenberger
right, exactly.
emergency landing in the Hudson.
Right.
Programming a robot with that kind of contingency planning is difficult.
Right.
Robots still, we don't know how to do, now we're getting into robotics and crossing into artificial intelligence, we don't understand how to do that kind of creative thought. We don't understand how to get robots to get, think of new things that aren't in their database. Think of, he had choices to make about what are all the possible landing places. And on his list was this big giant river. Unless some engineer thought to put that in the robot's list of possible places to land, a robot may not have considered that as a place to land. So you get into issues of inferring function from form. Is this a chair? Well, can I sit on it? Well, then yes. Well, that may be a chair. Well, is this a chair? Well, I can sit on it, yes, but this is, I happen to be, I speak IKEAN very well. This is a table that may not have enough structural support to hold my weight, so maybe I shouldn't sit on it. So there's issues of structure and safety that we understand, and we make choices. And teaching all this to robotics is hard. We're getting there, but it's hard.
You said artificial intelligence. Explain what is AI?
So the problem with explaining AI is that we don't understand I. We don't fully understand what intelligence is. We don't understand how we think. We don't understand how we're able to. So, okay, let's rewind. We don't understand how we're able to formulate plans and make decisions and do things that are different than what we've done before. So there's an upcoming Go match between a Go master and AlphaGo computer program that's coming up in a few weeks. Go has been the last frontier where machines cannot beat humans. And it may be the case that we're getting to the point where a machine can beat a human at Go. Go is the ancient game where you have white and black pieces and you have to capture area. It's either Chinese or Japanese, depending on who you're talking to.
Okay.
But chess fell to computers several years ago. Right. But the way those programs work, Jeopardy also, the computer did a very good job at Jeopardy. But the way those programs work is they have this massive database, and they're able to search large portions of the database. In the case of the games, they're able to search many moves ahead, and to search not just what's the likely outcome, but to search all outcomes. With chess, each move you make then enables a whole set of other moves. You make any one of those move, those enable another set of moves, so you get this branching of outcomes. Right. And if you have computers that are bigger and faster and hairier, they can search more and more of these outcomes until they can find the best path on each of these outcomes. Humans don't do that. So in the 60s, we tried to solve AI, in the 70s, we tried to solve AI by doing better and better searching. And we realized that AI is not search. AI is not searching big spaces. So then we said, okay, well, how about if we just react to the world around us? So this is in the 80s. We spent some time doing more reactive stuff, trying to, maybe you don't sense the wall until you get close to the wall. Maybe you don't have a plan. Maybe you are reactive. And that is useful, but has limits. If you're not making plans, you can't plan ahead. You can't predict what's going to happen and know what's next. So now, what is happening now is that we're making big strides in machine intelligence, machine learning, where we have big databases, and we're able now to draw inference from what am I looking at? Here's my database. What is this likely to be? Based on what I've seen before, what do we have here? And we're starting now to be able to marry inference and plans together, where I want to get into the next room while I'm holding a pizza. But first I have to go get a pizza, then I have to go to the oven to heat the pizza, and then I have to carry it to the next room. So I can now take my goal and then back off the different ways to make that happen. Well, what if the door is closed? What if the light to the room with the oven is not on? Then you have to add, as you get to the room, you discover new information, you'd have to replan. So the ability to do that are things that we're just now starting to get a grip on and being able to do that in real time. So But these things I'm describing, they sound very simple-minded, and it's really not clear if that's how we think. So the best test for intelligence is this Turing test, the famous Turing test proposed by Alan Turing in the 50s. And it goes basically like this. We're sitting here having a conversation, and you can see me, I can see you. You assume I'm intelligent because we're having an intelligent conversation. What if we were having this conversation by correspondence? We're sending text messages back and forth, and you can't see me. If you can not tell if I am artificial or real, am I intelligent? Basically, if I can fool you, am I intelligent? And another way to say that is intelligent something that I have, or is intelligence something you attribute to me based on your interactions with me? And the Turing test claims, well, intelligence is something that we attribute. If something can fool you, then it must be intelligent. If you cannot separate it, it must be intelligent, or that's the conjecture. We've never had anything that passes the Turing test, so we don't know if we can build something that can effectively fool us that we would call intelligent. And when applied to robotics, the Turing test would have to include not just spoken or verbal or written communications, but the look of something. Does it look intelligent? Is it moving through space in intelligent reaction? Is it making choices and you know, is it holding the spoon properly while it's eating? So crossing that robot Turing test is very hard and a long way away.
Where do you see the most advancement? What fields do you believe we will see the most change in?
Oh, there's a bunch.
In the coming years.
Yeah, there's a bunch. So the first things that look ready are the general class of tasks where you can control the environment and give some structure. So Amazon uses robots now to pick packages out of their warehouses. Farming has becoming heavily automated, where the tractors know where they are, the combines know where they are, they know where they're going. They have this notion of precision agriculture, where even the head of the pesticide sprayer or the fertilizer sprayer, each nozzle, like an inkjet printer, measures the amount of fertilizer on that spot and squirts only the amount to make it right. This is good. This is cheaper because you're not wasting chemicals. And it's also better for the environment because all the runoff is not running off the field. So tasks like that are ideal. We're seeing more medical robotics come online. Hip surgeries now, robotic hip surgeries are commonplace, where the robot helps the surgeon by preparing the hip, preparing the joint for surgery. We're going to see more and more endoscopic procedures that are robot assistive, where the robot can help the surgeon getting into a small confined space. We're going to see more teleoperated robots, more consult by robotics. Going a little further forward in the future, self-driving cars is what we started the conversation talking about. That's going to happen once we figure out how to get that going. More autonomy at home, robots that can even just, we have robot vacuum cleaners. How about robots that can pick things up? The proverbial get me a beer kind of robot. If your house is organized and neat and structured, yeah, that can happen. Robots have been delivering medicine and meals in hospitals for over a decade, and they cheat in some level by having magnets and stripes on the floors, but yeah, whatever, we cheat by painting the walls different colors and having lines, different color lines on the wall so you know where you're going in hospitals. And it goes on and on and on. And
fascinating.
The fear is that robots are going to put people out of work. But that has been true. Robots are technology, like any other technology. Technology has been putting people out of work since technology was invented. The cobblers are sad because machines make shoes. The basket weavers are sad because machines make baskets.
Wagon wheel makers, etc.
And you can go down forever.
Tell me, I have about 4 minutes left in the program, but tell me about these guys.
Okay, so these are the robots that I've got to show today. And these robots are, at this point, these are about 13 in robot years, which is about 1,300 in people years. So these robots are downright, they're past geriatric. They're into
ancient.
Ancient, right. But these were built when I was a research scientist at iRobot, and these are my demo kit. for talking about multi-robot systems. So my research was all about software for large numbers of robots. I wasn't interested in 10 or 20, I was interested in 10 or 20,000, very large numbers. And how do you get them to work together and to cooperate and communicate so that you can do things better than, or just fundamentally different than robots can do by themselves? And the key thing that makes these robots special is the communication system that's around their perimeter. So if you look right in there, you can see infrared lights, and then these are infrared receivers. And that lets the robots talk to other nearby robots and determine who they are and where they are relative to them. So that gives them a sense of their world around them, in the sense of where their neighbors are, where the other robots are. So when you know where all your other neighbors are, you have a lot of them, and a lot, again, measured in hundreds or thousands, well, now you can make a map of the building, not by finding all the walls, but you can make a map of the building by finding all the robots. If all the robots are spread out evenly, wherever the robots are is floor, wherever the robots aren't is wall. If you are, I mentioned Amazon, if you're delivering packages, the robots go bring the package to the people put the packages in the box. So you don't have to have people running around through aisles picking packages. You could argue that, well, there's a job that someone was lost, but the people who have done that job will tell you that this is not a bad job to lose.
Right. In about 2 minutes, where are robots most valuable with what we have today?
The classic answer to that question is tasks. Robots are best at jobs that are dangerous, dirty, or dull. So these are jobs that people just really can't do. Going to the bottom of the ocean, going to Mars, going to the moon. It's hard to get people to do these jobs. Those are dangerous jobs. Dirty jobs, cleaning out sewer pipes, cleaning out gutters, going through trash. You don't want to do this job. And then dull jobs, welding car frames over and over and over again all day long. So anything that the famous 3Ds of robotics, anything that meets that, robots will be good for that.
Wow, fascinating. The future is going to be awesome, isn't it?
It is. The future's
really
awesome.
Is. I get so frustrated with all the negativity, but when you look at what's happening in science, it's just awesome. What a pleasure. Thank you, my friend.
Thank you for having me.
James McLurkin visiting with us today. He's an engineer with Google, also an adjunct professor with Rice University. By the way, you can see more of our conversations online at wsre.org/conversations, as well as on YouTube and Facebook. I'm Jeff Weeks. Thank you so very much for watching. I hope you enjoyed the broadcast. Take great care of yourself, and we'll see you soon.
Support for this program is provided in part by these corporate sponsors. And by viewers like you.